2008, number 5, we have a differential equation. If you recall, I have to fill in the slope field, and I have to make sure that I hit all 9 points. So what I'm doing here is I need to find the coordinates of each point, and I'm going to sub in for x and y into my differential equation to find out what the slope of the tangent line is at that point. So my first point here is -1, 0. Therefore, dy dx is equal to 0 minus 1 over -1 squared. So at that point right there, I have a slope of -1. So that looks good. Let's see, my next point here is 1, 0. Therefore, dy dx is 0 minus 1 over 1 squared. That's also a -1. So I want to try to match those up because they both have a slope of -1. And then finally, I have 2, 0, which means dy dx is -1 over 2 squared. So -1/4. It's got to be negative slope but less steep. So maybe something like that. So now I'm going to go into the second row here, and this is the point -1, 1. Therefore, dy dx is going to be 0 over 1, which is 0. So that's going to have a slope of 0. And now that I think about this, all of these 3 points here have a y value of 1, which means when I sub it into the derivative, it's always going to be 0 over something. Therefore, the slope on all of these is going to be 0. So now I have just the top row to do. So I've got the point -1, 2, and that's going to give me, let's see here, 2 minus 1 over -1 squared, a slope of 1, about the same steepness but positive. And then I have the point 1, 2, which is going to give me a 2 minus 1 over 1 squared. That's also a positive 1. And then I have the point 2, 2. So 2 minus 1 over 2 squared. So that's going to be a positive 1/4. Again, same steepness, but now positive. So maybe something like that. Those are our slopes. Now part B. This is the big one. Find the particular solution to the differential equation with the initial condition. Alrighty. So my initial condition is f of 2 equals 0. This is part B. Particular solution means there will not be plus c. When there's a plus c, that's called the general solution. So my equation, dy dx is y minus 1 over x squared. And I have to multiply both sides by dx. And then I have to divide by y minus 1 because I need to get that over on the left-hand side with my dy. Let's see here, dx over x squared. Now, whether you write that 1 over x squared dx or dx over x squared, it doesn't matter. Same thing. So there's that. And now what I need to do, now that I have y's together, x's together, now I can integrate both sides. This would require a u sub. Du is dy. So that's going to be the integral of du over u equals the integral of dx over x squared. So when I integrate this, let's see, left side I've got ln, absolute value of u, which is y minus 1, is equal to, well remember, this is really x to the -2. So when I integrate that, I'm going to get, what am I going to get? Let's see, x to the -1 divided by -1 plus c. Add 1 to your exponent, divide by the new exponent, there we go. So now I'm going to bring back down my initial condition, which is f of 2 equals 0. Bring that down, and I want to sub that information in. So x equals 2, y equals 0. So I have ln, absolute value of 0 minus 1, equals, now this is really just a -1 over x, which in this case is 2, plus c. I'm just rewriting that fraction right there. Negative exponent, that goes to the denominator. This negative, I'm just going to stick in front. Well, this turns into, let's see here, a -1 inside the absolute value. So I have ln of 1, and then plus 1/2 is equal to c. And of course, we all remember that ln of 1 is 0. Bam, c is 1/2. So now I know that c is 1/2. So what I'm going to do is I'm going to take that in my equation, and I want to set this up. So I have ln absolute value y minus 1 is equal to negative 1 over x plus 1 half. So there's my equation right now. Now I need to drop the base. E to the negative 1 over x plus 1 half is equal to absolute value y minus 1. There you go. Definitely need those absolute value bars. Now in this case, I normally split up my e and split up my exponent, but in the past we've had ln's in here, so when I split it, I can cancel because I would have e raised to the ln of some number. I don't have that, so if I did split this up, it's not going to help me. I would end up with e to the negative 1 over x times e to the 1 half. It doesn't make it any easier, so I'm going to leave it alone for now. So I'm going to branch this off and say, okay, y minus 1 could equal a positive e to the negative 1 over x plus 1 half, or y minus 1 could equal a negative e to the negative 1 over x plus 1 half. So those are my two options for equations. And again, I have to pull in my given information, f of 2 equals 0, from the beginning of the problem that was given to me and check to see which one works. So if I put 0 in for y, then I get negative 1 equals e to the, let's see, 2 goes in for x. So negative 1 half plus 1 half. Well, that's going to be e to the 0 is equal to negative 1. Well, negative 1 is equal to e to the 0 is 1. That doesn't work. If I test this out over here, notice that negative in front is going to give me the negative 1 that I want. So everything will work. So I have to take this equation, but I have to make sure I solve for y. So my final answer is y is equal to, add 1 to both sides, 1 minus e to the negative 1 over x plus 1 half. So that's your answer for part B. That's your particular solution. Now, let's find the question. Part C, what I have is, let's see. I need to find the limit as x approaches infinity of the answer that I got. So here's the good news. If you got some other answer, as long as you're finding the limit of your equation, that's what they're asking for. So you could still get credit even if you made a mistake up here. So I want the limit as x approaches infinity for 1 minus e to the negative 1 over x plus 1 half. Now, if you recall, when we did limits to infinity, we always plugged in, quotes, plugged in infinity. Obviously, that's not a real number. I can't really plug it in. But I put infinity wherever an x is to kind of see what's going on with the problem. So if I do that, I end up with 1 minus e to the negative 1 over infinity plus 1 half. Now, do you remember when we talk about what's getting bigger faster, the bottom or the top? In this case, the bottom's getting bigger faster. So that whole fraction right there is going to 0. That's turning into a 0. So essentially, that part of my exponent disappears. Therefore, my limit is equal to 1 minus e to the 1 half. That's my limit as x approaches infinity.